we discuss about 8051 timer and interrupt programming in assembly and C. In our previous lecture, we learned about the timer register of 8051. Now we are going to give you details about the timer programming and interrupt service of 8051 in both assembly and C. So you have doubt that why we learn the assembly, because we seen that if we program using C, that it is easier to write or program our algorithms, but it generate excess bit. You know that the RAM size is very small in case of 8051. So extra bit which generated by C language, it consume RAM, whereas the assembly program generate less byte, but it is difficult to write the program in assembly language because you have to know the details about the assembly language. Whereas in case of C, it is easier to decode. So you have to trade off between the assembly and C. So it's always preferable that to write the program in assembly language instead of C. Another advantage of C language, here I say C, but it is actually embedded C. So you have some idea about the embedded C, because it's though it look like the C, but since this C program assembly instead of the C program, that is embedded C, is generally compatible with other program software. So it's totally depends on the assembler that how it decode the C program. But in case of the assembly language, when you write the program in assembly language, it is tough to write because you have to know the codes, mnemonics of the program, and it's differ from microcontroller to microcontroller. But embedded C is similar for all type of microcontroller. So without wasting our time, we start the first, that basic register of the timer. So in our previous discussion, we learned that there are two types of timer present in 8051. We call it timer 0 and timer 1, which are 16 bits wide. And each 16-bit timer is accessed as two separate registers of low byte and high byte. Now timer 0 register, we already discussed that TL0 and TH0, and it can be accessed like any other register such as A, B, R0, R1, R2, and we can also use the value of timer using the command move TL0 has 4 FH, means in TL0 the number 4F. 4F means 0, 1, 0, 0, and F means 1, 1, 1, 1. That is the 4, 1, which is represented in hex code. That it moves the value 4F into TL0. So in the same way, we can save the value of any register, that R5, in TH0 bank. That is, the high byte of the timer 0 is equals to the value which is saved into the register R5. So move, using the move command, you can save the value as per your desire. So this is the timer 0 and TH, that is high, and TL for 0 bank. So programming of 8051 timer, the timer 1 register is also 16-bit, and it's split into 2 bytes, TL1 and TH1, and it also accessible same as this, that move TH0 comma has the value in hexadecimal, move R5 comma TH1, that value of R5 will be stored at TH0 or TH1 byte as per your requirement. And to access the register, we have to use TMOD, that is timer mode register. So timer 0 and 1 is use TMOD register to set the operation. So let what happens in mode 0, mode 1, mode 2 and mode 3. So look at that. Mode 0 is 13-bit timer mode, 8-bit timer counter with TH0 or TH1 with TL X, X may be 0 or 1 as 5-bit prescaler value. So it is actually 13-bit timers. And mode 1 is 16-bit timer mode. You can use as a counter also. But since it is 16-bit, so there is no prescaler. Now mode 2 is 8-bit auto reload. 8-bit auto reload timer or counter where TH0 or TH1 holds the value that's to be reloaded into TLX. So the value which you store at the THX bank. THX bank means TH0 or TH1, the holds the value. Suppose it holds the value FF. So the timer, it's given to the its lower byte, where this lower byte count that value, and after that it reset automatically. And the split timer mode is same, that you can stop and start, stop and start. Suppose you want to count the total event. Our previous class which we discussed early, and you also get the video link of this mode register program. Now how you program the 8051 timers. So you know that in case of 8051 timers, It's also work as the counter. So the value of C by T, where in the mode, look at C by T, actually T bar. So either this bit 0 or 1. So when it is 0 or when it is 1, the detailed discussion we already done. So if C by T equals to 0, the crystal frequency attached to the 8051 is the source of the clock for the timer. Since 8051 is not included the time crystal inside the chip, you have to attach the crystal externally, and there is separate circuit, and that circuit contain a crystal, and this crystal generate the frequency, and the frequency which is generated always 1 by 12 the frequency of the crystal attached to the 8051. So you have to remember 1 by 12. So the frequency which is generated by the crystal is automatically divided by 1 by 12. And why 1 by 12 is totally depends is totally done by internally due to the different circuits present in clock. So every program, it may be in computer or any other microcontrollers, is totally run through a clock pulse. So when the clock pulse is appear, the processor is active to execute that code. So you can consider that clock pulse as a trigger. So triggering means that it start work. So the timer frequency is 1 megahertz. Since our crystal frequency we consider the 12 megahertz. It's actually depends